We want to find a degree 3 Taylor polynomial for the inverse sine centered at 0 and then use it to approximate the inverse sine of 0.2. So the first thing we want to do is find the function at 0, and that is going to be the inverse sine of 0. Remember, inverse sine says what angle sine is 0, and this is going to be something between negative pi halves and pi halves, so that's going to be 0. Now we need a derivative of the function, and if we remember, the derivative of inverse sine was 1 over the square root of 1 minus x squared. So if we take that and we evaluate that at 0, we get 1. Now we need a second derivative, and we'll go ahead and think of this as 1 minus x squared to the negative 1/2. So we can do a power rule chain rule. So power out in front and decrease the power by 1. That'll make that negative 3/2, and then multiplied by the derivative of what's inside, negative 2x. So it looks like our negatives will cancel and our 2's will cancel. And now let's go ahead and evaluate this at 0. And so because we have this x right here, putting in 0, multiplying it by this, we will get 0. Now we need a third derivative. And that one is going to involve, let's rewrite this. This is x times 1 minus x squared to the negative 3/2. So this is going to need a product rule. So we have first times the derivative of the second, which would be power out in front, decrease the power by 1, multiplied by the derivative of what's inside, and then we have plus the second function, so 1 minus x squared to the negative 3/2 times the derivative of the first function, which is 1. And we need to evaluate this one at 0. Okay, on this one, because we have some x's here, putting in 0, that's going to be gone. And over here, putting in 0, we will get a 1. Okay, now we are ready to write down our Taylor polynomial, degree 3, that approximates this function. And so our constant term was 0, and then on our x term, our coefficient's a 1, so that will just be an x. And then if we look, our x squared term is also 0. And then we look at our x to the third term, its coefficient is a 1. We need an x to the third, and we need to put that over 3 factorial, which is 6. So here is our approximating polynomial for inverse sine. Now we're going to use that to estimate the inverse sine of 0.2. And so that would be putting in 0.2 plus 0.2 to the third over 6. So I'm going to bring up a calculator to do that. We have 0.2 plus 0.2 to the third, and that's divided by 6. And so that is approximately, we'll list maybe 5 decimal places here. We have 0.20133. Now let's actually compute the inverse sine of 0.2 and just look and see how we did. So we got the inverse sine of 0.2. And that, if we did the inverse sine of 0.2, that is approximately 0.20136. So as we compare those, we see by just doing a very simple polynomial here with 2 terms in it, we get a decent approximation out to, we wouldn't have an error until the 4th decimal place. So that's one of the beauties of Taylor polynomials, a very simple function to approximate a more complicated function.